I'm Gayatri, working as assistant professor in EC department at SNS College of Technology. Today I'm going to discuss about the topic which is design thinking approach using the smart antenna alignment, particularly used in plane wave applications, which is under the Unit 5 plane electromagnetic waves studied by second year students in electromagnetic fields and waves. As the SNS institution, we are following the design thinking approach, which is based on the 5 stages, which is empathy, define, ideate, prototype, and test stage. In the empathy part, we can analyze the pain points of the user, and the define we have to give the solution for the particular problem. In the ideate part, we are proposing some methods or protocols used for identified in the empathy part, and the prototype we are designing one particular model for this definition part, and test we are using this in the particular applications. The first in the design thinking approach, I am going to take the topic which is smart antenna alignment used for particular plane wave applications. The antenna alignment, which is majorly important in the particular electromagnetic wave propagation. The empathy point of the user is that when we are aligning the antenna manually, which is time consuming process. The major drawback is that time consuming, and also when we are aligning the antenna manually, we can get the signal losses. When the signal losses is there, the communication quality also reduced, and when we are aligning the antenna manually, the experts are required for this particular antenna alignment. And keeping this the pain points of antenna alignment system, we are defining one particular method which is the automatic antenna alignment system. In the automatic antenna alignment system, the automatic operations are involved, which is reducing the human interventions, and also human errors also reduced when using our automatic antenna alignment system. And compared to manual technique, the signal quality will be also improved, and there is a high accuracy, and the implementation of this antenna element which also low, and the real-time tracking will be available when we are applying the automatic alignment system. And coming to the ideate part of this proposed smart antenna alignment system, when we are having manual alignment, the technique advantages which is simple, and the limitation which is inaccurate. And when we are using the GPS based, the advantage which is automatic, when we can manually track this alignment technique, and the implementation of this GPS is expensive. And the third method, which is signal strength scanning method, we are in a particular period of time, we have to scan our the signal traveling from transmitter to receiver. The advantage of this method is reliable, and the accuracy will be low when compared for the signal strength scanning. And the fourth method, which is plane wave based smart alignment technique, it is most accurate and fast and requires the signal protocols. And so we are using this smart antenna alignment system for particular plane wave application. And the taking the concept of plane wave, there is electromagnetic field will be present, and magnetic will be present, and electric field and magnetic field will be perpendicular to each other, and it is separated by the distance of lambda, and it is traveling with the velocity of light. This is the concept of this plane wave. And coming to the proposed system architecture of smart antenna alignment system, we have to use the antenna array, RF receiver, RF transmitter, and Arduino board is used, and signal processing unit, servo motor, and LCD displays to monitor the tracking of this particular components. And the workflow of this tracking is that we have to transmit the signal, and it is sent to the antenna array. The array is nothing but it is having one or more antenna elements, and we have to use a phase deduction, we have to and the angle calculation will be done by using formula, and motor rotation and alignment will be particularly noted down. And coming to the prototype design part, we have to use a dual antenna setup method and ESP32 controller and servo based rotation method and real time signal monitoring. When we are setting this MIMO antenna, the signal reception and transmission will be better when we are using this antenna alignment technique. And coming to the servo based rotation method, it employs a precise movement and ability to various scenarios, and real time monitors will allow the user to track the performance of this particular antenna alignment system. And application, it is used in the communication part, satellite communication, IoT network and drone application and smart cities. This antenna alignment system will be used. Let us summarize this topic. We have taken this smart antenna alignment system in the 5 stages. We have described this particular antenna alignment system. In that, the antenna alignment system using the plane wave is designed, and it is efficiently used in satellite and IoT applications. These are the references. Thank you.